name is John Arndt. I'm an employee with engineer with Architectural Energy Corporation, and I'm going to be speaking about today about the COMNET reports that we've developed, as well as the XML schema that we've developed to represent the data for those reports. So the schedule we have, this is the fifth in a series of 13 sessions we have to review the COMNET material. We're reviewing the standard reports in the XML schema. Next week, Snow Price is going to be discussing the energy costs methodology and results that are used for COMNET. And then after that are a series of sessions that really dive into what are referred to in COMNET as the building descriptors. These are the unique inputs that represent the data inputs for the energy model. So today I'm going to be discussing the COMNET XML reports. The XML reports that we're using mainly to store information from the outputs of the energy simulation, those that are needed for the rating authority, whether it be for compliance or whether it be for a lead rating. So we're taking the outputs from the simulation data file, which could be the DO2 BDL or the input file for the Energy Plus, and after the simulation engine runs the simulation, we're going to take the software, I guess I should say, would take the output file and then store that data into XML format. And that XML data could be then transferred directly to the rating authority, and then the rating authority would have the capability to store that data into the format that they need. As well, COMNET specifies 4 standard reports. These are the reports to be generated in print format. And we have, for these 4 reports, we have a building summary, which is a summary information such as the project address and so forth. Energy measures, which are a user-defined set of efficiency measures for things that exceed code minimum or exceed the program defaults. We have energy reports, which is an energy summary of the proposed building as well as the standard design or baseline building, as well as an end-use breakdown. So we have the capability to store end-use data from the energy simulation. And then representations are simply verifications from the appropriate authorities, be it the energy modeler or the engineer, that the information is accurate. And then something that was done after the initial work on the COMNET Modeling Guidelines and Procedures Manual is that we added to the reports, we added information in the schema to make it compatible with the requirements for LEED Online for the EA Credit 1 as well as the prerequisite. So all of the information that's required for LEED Online we've tried to capture in these reports so that these reports could be used for LEED reporting, both for complying with the prerequisites as well as demonstrating that a certain number of points or credits have been achieved per percent better than the minimum requirements. So as I mentioned before, we have the energy use and end-use breakdown by period, so this could be either monthly or hourly. And then we also provide a data structure and capability for storing the energy use information for each orientation, which is required by LEED. This is just a level of abstraction COMNET schema that we have, it shows that at the root level we have a project data or a report that encompasses all of the report information. So again, this is just, these don't actually represent data elements in the schema, but it's a slight level of abstraction. And then we have stakeholders, which are all of the stakeholders, such as the architect, the design engineer, the building owner, etc. And we have, for each of them, we have contact information. So in this diagram, the infinity symbol just represents the fact that we don't place restrictions on the number of stakeholders or the number of subspaces, for instance. So we have subspaces, which are sub-occupancy information for within each space. Energy efficiency measures, we have a listing, and this is more user-defined. There aren't really restrictions placed on the schema of efficiency measures for things that exceed code minimum or exceed the defaults that are set forth in COMNET. The annual energy results, and then for each of those results we have a energy results breakdown, which is the end-use breakdown by time period. Representations, as I mentioned, which is a more formal authorization that the material presented in the report is accurate. Any advisory messages, such as things, for instance, I think one example would be if you exceeded the preset limit of the unmet load hours might be one example. Any kind of warning messages that might pop up from the simulation would be stored in this data structure. Lastly, any explanations for default overrides. We have some things that are defaults or critical defaults even in COMNET where they're not meant to be changed unless there's sufficient justification for overriding them. This is an example of the print report for the project data summary. So we have the project title and address, condition area and unconditioned area, some basic building geometry characteristics such as the window wall ratio, the principal building activities, so this could be, and then we have some other basic information about the simulation. So that was the print report, and now here's a graphical representation of how we've implemented this in the schema. Is we have a data type called project data type, and it encompasses each of those. For each of those pieces of information, there's a data element, such as the project name, the address, which is itself a structure, number of stories. And then for some of the numeric values where you would want to specify the units, the way we've handled that in the schema is to define an attribute called units. So for things like condition area, you want to know whether it's square feet or square meters or so forth. And then a couple other items just to point out to clarify what these are. For those that may not be too familiar with COMNET. So we have a purpose. The purpose really defines the baseline for comparison for your proposed building. So whether you're doing tax credits or whether you're doing green building ratings or compliance with California, which we're it defines the purpose defines what you're being compared against and what kinds of credits you can take in your simulation. And then one last one is the currency. So currency defines really what is the energy metric that we're defining for this. You know, is it site energy? Is it source energy? Is it time-dependent valuation that California uses? So it's defining the energy metric that's used for comparison. And then lastly, at the bottom, I've defined a data structure called lead project data, which encompasses the lead-specific elements that you would need for reporting for the EA Credit 1 or the EA prerequisite. So I tried to compartmentalize all of the lead requirements into a specific data structure, and I've tried to identify all of those data elements with a prefix of lead so that we know that it's specific to something that's specific to lead, but that wouldn't be necessarily needed for other purposes. So this is just an example of the schema code excerpt for the units, showing the units, and it shows the condition area is a data type that has a type decimal as well as an attribute called units, which defines the units for the values. So this is just an example of the XML schema. I think it's a lot easier to look at graphically, so I'm not going to spend much time on this actual schema code, although it's certainly available, of course. But we can come back if there's any questions on the actual schema. But I'd prefer to focus on the graphic representation of it so that we can see what it encompasses. More examples. So as these are the two I mentioned. So for purpose, the reason I'm showing this is we have some in the XML schema. We have a way to restrict the data inputs, and the way we do that in the XML is with enumeration. So for purpose, we have defined federal tax credits, green building ratings, Title 24 compliance, and Title 24 reach. And then for currency, as I mentioned, we have source energy, site, cost, energy cost, and TDV. So those are ways to restrict the data so that not just any arbitrary value can be entered. The lead project data, as I mentioned, these are specific things that are required for the lead reporting, the compliance report, things that we don't necessarily use for other purposes, such as far as reporting heating degree days, cooling degree days, the ASHRAE climate zone. One thing that's also defined in lead is they differentiate new construction versus any existing renovated or unrenovated area, so we can make that differentiation. All right, the next report, this is the print summary that we have, which is also in the COMNET MGP, is the Energy Measures Report. So what this is intended is to identify the primary measures that are used to basically to exceed code minimums or exceed the minimum requirements, say, for lead. So anytime there's something that's either not a default or something where the insulation exceeds code minimum, then you would specify it on this report. So for instance, the roof insulation, if the baseline was R15 and you had a proposed value of R25, then you would document it on this report so that that could be easily viewed without having to look at the details of the energy model inputs. So how is this represented in XML? We have an efficiency measure type report data structure, and again, on the far left here of the screen, the 1 to ... indicates that there's no upper limit on the number of efficiency measures you can define in the XML report. And then we have a description. Here, the baseline and proposed design actually indicate the baseline building value for that efficiency measure and the proposed design value for that efficiency measure. So this would have, in the case of the insulation that I just showed, the baseline building value would be R15 and the proposed would be R25. So this enables you to identify all of the efficiency measures that are used in your energy model. Efficiency measure type, again, this is just another example of input restrictions, we classify the measures by what type of measure it is, and we've defined envelope measures, HVAC, internal gains, such as equipment loads or plants. The next report is the energy summary. This is one of the 2 pages, which is also shown in the COMNET MGP. And so for the end-use summary, we have a comparison of the baseline and proposed, as well as the difference, and then the percent savings. And then it's broken down in end use. And the other thing you'll notice for this example is that the metric we're using is source energy, source kBTU. In addition, we have a more detailed breakdown by end use into both electricity and gas. And then this report is shown as a monthly breakdown. So it shows that each of the end uses, the lighting, space heating and cooling, pumps, fans, etc., in a monthly end use breakdown. So for that first page, the high-level summary, we have an energy results type that we've defined. So we have a fuel, the end use, whether this is a Boolean, whether or not it's a process load, and then we have a proposed design and baseline building energy use. The currency is, as I mentioned before, what we're using for our energy metric, whether it's site, source, cost, or TDV. And then this energy results breakdown data structure has the more detailed breakdown of the energy use. One thing that's done for the baseline is we have a structure, and this is required for the lead reporting, is to identify what the energy use is for each of the buildings' 4 cardinal orientations. So I've only shown 2 here because of the limits of trying to show everything on the screen, but there's a data element within the structure baseline building called baseline rotation 0 degrees, which would indicate what the energy use was for that orientation. So you would have all of that information available within this single element baseline building. Energy results breakdown, here's the graphical representation. Again, this is the end use breakdown. And the one thing that I'd like to show, let me just do a time check. Okay, the one thing I'd like to just show on this one and point out is that within this data structure we have something called a time period and a time. So the time period would be what is the time increment that you're looking at for your end use breakdown. Is it monthly? Is it hourly? Is it something else? And then the time would actually be that specific time, whether it's January or whether it's a certain hour of the year. So with this, we've made it flexible so that you can report, not just monthly, but you have the capability to report hourly data within this data structure. And again, this just represents in the schema what I've just said as far as being able to show an end-use breakdown for any user-defined time period, either monthly, hourly, or other. Advisory messages. This really contains any warnings from the simulation, number of defaults that were overridden. This can be defined in this data structure, as well as the hours for unmet load hours for heating and cooling. There's some specific rules in COMNET for sizing equipment such that the number of unmet load hours don't exceed a certain amount. Override explanation, this just contains information for any opportunities for documenting an explanation for when any critical defaults of building descriptors are overridden. So this just provides an opportunity to document that. And then the representations, as I mentioned, this provides a more formal way for those to document contact information, what their role is on the project, and for those, the representation itself, those for titles for when say if a professional engineer or BEMP is required to certify that the results are sufficiently accurate. And that's about it. It was a pretty quick summary of the information that we've had. I've tried to highlight the information that we have in the schema, as well as showing you some of the snapshots of the actual schema itself, which is an open source text file. You can find more information on COMNET at comnet.org. You can contact Charles or myself at the email addresses listed.
So thanks, John, for a very good presentation. That wraps up the presentation on our standard reports in the XML schema, and we'll now open it up for questions. Thanks very much.